What does machine learning mean? It means you create a model, you train it, you evaluate it, and then you get predictions out of it. That's what this service does for you. Where is it getting the data from? From different data sources. You can get it from S3, you can get it from your relational database, your MySQL, for example, and obviously the data warehouse, Redshift, S3, RDS, and Redshift. This is where we get the data from. We can then create a model, and then we can request predictions, both in batch, right? So give me a predictions for those hundreds, thousands different user, or in real time. This is the current user, give me a prediction for it. So let's look at that a little bit further. 3 steps with Amazon Machine Learning, just like with any machine learning. Basically, train your model, evaluate it, and retrieve the prediction. So let's look at the train model first. This means that we're going to create a data source where we're taking the data from for which we want to train the model, and we want to explore it, understand it a little bit better, maybe clean it a little bit further before we train the model, and then effectively train the model. All right, let's go to this step by step. These are actual screenshots from my console. Apologize, you might not see that very well from behind there, so I'm just going to talk you through. So the first thing is creating a data source. So this is where you define your location of input data. So this could be your data warehouse, your log files in an S3 bucket. You put that in here, and then you say load it up. What Amazon Machine Learning now does, it loads up that CSV file, for example, and it tries to find the different data types that are in there. So here's an example where we see age, and campaign code, and contact, and it found that age was numeric, for example, between, well, this is an old data set, 50 and 57. And it gives you certain sample values here of what it found in that data source. So this is just an additional go-through. This allows you to define the data type. So age is a good example. Age can be numeric in the sense from 0 to, as old as it gets, I guess. Or it could be a class, right, where you say from 0 to 18, from 18 to 25, 25 to 35, and so on. This is the place where you can modify the data type and say, what is it actually that I loaded in? We, by default, try to determine that, of course. And then the important part is the target variable. So what our machine learning service does for you, it can give you a prediction against the target variable. Think about a classification algorithm, for example. Think about, is he going to buy this or is he not going to buy this? A yes or no answer. That could be a target variable. So as you know, when we train a model, we obviously need to know the outcome so that we can train it. And then later, the outcome is we want to have predicted. So here we then select that target variable where we say our data set with which we train, here we have the target variable and we know the answer. And this is what later you should predict after creating the model. Then we review it, and that's it. Now we create the data source object. Everything is an API, so we can also do that programmatically. Since I talked to a bunch of data scientists here, this is Python code. So it is available in both Retrieve for yes, it should be. It should be. This is the latest Bodo version where it runs on. So I think that should be Bodo 3. Give you the details later to make sure that it's in there. It should be in there for sure. Unless you use a very outdated Bodo library, which Bodo 3 isn't. It's one of our newest. So yes, should be available there. And this is the way it would look like. So that initial creating data source would be loading up Bodo library and then creating the data source. Here we just loaded up from an S3 bucket. This is just a sample. All of this has been done also to the console. It's just to show you, sometimes it's nicer to just do it all in like 3 lines of code. Now, after we created the data source, what Amazon Machine Learning also helps you to do is to explore and understand your data. So it loads it up in, and then it gives you certain distributions, for example, and plots it out for you so you can explore the data. And that doesn't look very fancy, but I want to point out one thing here which is fairly interesting, which is something I always talk about. When we want to build a good model, we want it to be not noisy. We want it to be good input data. So what does that very often translate to? to a good correlation from the input data property to the target variable that we want to predict. So if you load it in, Amazon Machine Learning does that, exactly that for you. So this column here is super important if you don't know if you should or should not keep a certain property when creating your model, because it gives you a correlation to the target variable. So obviously the more correlation there is, the better that property can help us create a good model. If we have a variable that has a very low correlation here, we probably should remove it. Right? We should consider removing it because it's noisy. A very simple example that I always give here is if you want to predict a certain thing about your user, like you want to find out is he a hardcore gamer, is he an occasional player, etc. And you have all kinds of information from that user, like his email address, his phone number, his transactions, his game sessions, etc. If you measure correlations to target from something like an email or phone number, do you think it's going to be good? No. There will be very low correlation. Your phone number doesn't tell you what kind of gamer you are. Very unlikely, right? Unless you have a very specific one, like 888888 or something like that. Then maybe a very lucky gamer. But you find that properties like this, you want to measure correlations first to decide if you want to keep them inside or not. So even though this is just in one slide, some people overlook this. I think this correlations to target is fairly useful for you to get initial hold of your data and remove what you don't want to have. It obviously visualizes also categorical attributes. You can dig into some sample records and say, give me some sample records to further kind of evaluate it, give you distribution of numerical values, etc. So for example, here age, we see that's an interesting curve. Where most people are 30 years old here. This was actual data coming from a bank accounting system. Now, after we create a data source and we explore it and we now decided on what attributes we want to keep or not, we obviously want to start training the model. So how does that work? Well, we select our input data. This is the data source that we created, so we just select it. Oops. And then based on the target variable, Amazon Machine Learning will now give me a model type. So if my target variable was a numerical value, it will determine that's a linear regression algorithm that should be used here. You can further fine-tune that if you want to do it. In this scenario, just said that's fine with me, so I'm going to start training that model. What it will do by default is it will take 70% of the data source that you included to train the model, and it will take 30%, cut it out, for further evaluation, which is our next step. And obviously, this can be done through Python code with the Boto library, of course. So here we just say we want a linear regression model being built on that data source that we imported. Now, the next step is, after we train the model, so now Amazon Machine Learning churns and it creates a model for you, we now want to evaluate if that model is good before we actually throw predictions against it, and potentially optimize it if it's not good yet. So this is the second step. So we explore the model quality. So depending on the model that you choose, it will look like this, which is an area under the curve that tells us how many false negatives and positives we have. Whoops, that was too quickly. Or here we have a numerical prediction target, a multi-class classification. So you can see kind of like, where's my distribution? How is it performing? How many errors do we have? And it also translates that to you into one average AV1 and baseline score. And that score obviously tells you how good that model performs. This is a value between 0 and 1. If it's 0.5 or below, it's for binary classification, that would be as good as random guessing. So that's not what we want to have. So we want to have something generally between 0.665 all the way up to 0.99192. If it's above 0.9 something, if it would be 1, then you have an overfitted model. So that's not good either. So you want to have a score roughly there. We highlight that with you by colorizing it. So it would be bad, it would be red. Here it's a good model, and we say, well, it's a better baseline. Sometimes we say it's a very good baseline, etc. So it gives you an idea of how it's performing. How do we evaluate that? 30% of your training data was used to evaluate this. You can also fine-tune those models. So here I used this was a binary classification, so it will give me this area under the curve, and now I can move around this needle to kind of play around if I want to have more false negatives or more false positives, by basically cutting off my threshold a little bit earlier. So it would look something like this, and swipe that around and find what you feel more comfortable with. I think the false negatives and false positive element is fairly important here, because for some of the stuff, the false negative might just be okay. Sometimes that's a really big issue and you rather prefer false positives, for example. So it allows you to quickly adjust that and fine tune it. Now after that, we now train the model, we evaluate it, we say it's good, let's throw predictions at it. So how do we do that? Batch predictions is the first one, is to say, okay, I have a large amount of volume of data that I want to have predicted. How would I use that in a business scenario? Well, I want to send out a marketing campaign to my customers. But before I do that, I want to know, who are the customers of my database that I should target, for example. That's a good example. Here I dump down a data source of all the data that I want to have predicted, and then I can request that through the Service Console or also the API, of course. So Service Console would be create new batch prediction, click. Here's my CSV file or my input file, whatever it is, and it will throw predictions at me, or via an API. Here's Python code again, so I could just request a prediction like this, and the outcome will then be an output file that would be put into your S3 bucket. So here we did a binary classification, which would basically give me yes or no, so 0 or 1, and then it also tells me the score, which gives me the amount of accuracy that we have, so how accurate we've done that prediction. So if we get a good score, obviously then that's something that we want to keep. The same thing can be done in real time, so this is great if you want to immediately react upon what people are doing, so something within your website, for example. If you want to straight away get a prediction of what your users are using within your website, then you can do that again through the API or also the SDKs that we offer. How would it look like? Something like this, for example. This is Python code where we say, use this model and predict it with what? Well, here's the input. I just put key value pairs here. Obviously, this would be the information that you gave the model earlier when you created it. Like his